Question tells you there is a physicist works in a laboratory where the magnetic field is 2 Tesla, and she wears a necklace of enclosing area 0.01 meters, but in such a way that the plane of the necklace is normal to the magnetic field. Means if this is the necklace, magnetic field is perpendicular to the plane. Okay. An initial magnetic field is given as 2 Tesla. Area of the loop is given as 0.01 meter square. Necklace is normal and the resistance of the necklace is 0.01 ohms. Because of power failure, the magnetic field finally decays to 1 Tesla in a time of 10 raised to minus 3 seconds. What is the heat produced? The heat is nothing but a form of energy. Okay, I know step number 1 will become E is equal to d phi by dt. Flux, remember, is NAB cos theta, but theta over here is 0 because it is the angle between the area vector and the normal. That is theta is 0. So can I say number of turns to hai nahi? So can I say A? Ye ho jayega dB by dt. E will become area. Area is 0.01 dB. dB is change in B. That is 1 Tesla. And our time is given as how much? 10 raised to minus 3. So ये हो जाएगा plus 3 into 0.01. That will become 10 volt. This is the EMF induced. Now, इस EMF के कारण what will be produced better? Power. Current is E by R. That is 10 by R is 0.01. 1000. 1000 ampere is very big number, man. Yeah, it is given. So fine. So, what is heat ka formula? Power ka formula? EIT. Power is heat is EIT, energy. E is given as 10 into 1000 into time is given as 10 raised to minus 3. So ये हो जाएगा 10 joules. Because if you look at the answer is given in joules. Joules matlab indirectly they are asking you what? Energy, and energy is EIT ना, पढ़ा है ना VIT. Energy is work done ना, work done is VIT. This is how you do it. I'm just wondering, 1000 ampere is a very big current. ठीक है, यहाँ पर दिया हुआ just 1000 ampere current. Okay, the person will not survive only, no, wearing the necklace. Okay. Question number 64. A wheel metal has a wheel with 10 metallic spokes, each of this much 0.5 long, rotated with the speed of 120 revolutions per minute. So how much is the length of the spoke? 1.5 meter. Speed of this much, this is frequency, 120 revolutions per minute, मतलब ये हो जाएगा 2 RPS. In a plane normal to the magnetic field, so magnetic field is this way. And you can see that the spoke, the cycle wala sum, we have done it initially. It is rotating with, if you remember, it had spokes and it is rotating. Because rotating with an angular speed of omega. The induced EMF between the rim of the wheel and this much. So whether there is 10 spoke or whether there is 1 spoke, I told you they all are in parallel, so EMF will remain the same. EMF ka formula, if you remember, is BL square omega by 2. But omega I can write as 2 pi f. So EMF is going to become B pi L square f. That is, magnitude of magnetic field is 0.4 Gauss. Gauss is 10 raised to minus 4 Tesla. Pi ka value is pi. L square. L square is 0.5, ka square is 0.25, and frequency is given as 2. You see this answer, you get the answer in bold. Answer comes, okay? 64 answer will come D. That is 6.28 into 10 is to minus 3. That is all okay. We need to know this formula. And this is EMF across each spoke as well as all the spokes. Why? Because they all are in. So these are all favorite questions of the examiner. They continuously repeated. This type will be there. Okay. Now, if I remember one question in this, they can ask you about a disk also. Disk is rotating in a magnetic field. Can I imagine disk to be made up of infinite spokes? A full disk is made up of how many spokes, beta? Infinite spokes. Can I say same formula will be applied across each spoke as well as the whole disk? Hello, bhai, bolo. And what will be L replaced by over here? What is L?
R.
R. Perfect. So EMF induced across the whole will become B R square omega by 2. Same thing. They can ask. Okay, fine. We are going to the 67th question. Okay, 60. Okay, aeroplane ka sum, if you remember, 65th also. As I told you that the aeroplane is moving. So an aeroplane, which is the distance between the tips of the wings, is given as flying horizontally from east to west. So there is an aeroplane which is flying from east to west. Barabar kya? This is the direction of velocity. Now, can you tell me which lines will it cut? Which lines will this aeroplane ka wings cut? Wings are these, okay?
BV.
BV, it will cut BV lines, okay? BV lines are how? Vertical. Na? This way. The wing is passing this way, it will cut this way. Na? Okay. Can you tell me what are the formula for EMF induced? BLV, but BVLV? You know it, right? You're not doing it, you know how to do it. Right. All questions are same, repeated only. See, a conducting square loop of length L is moved out in a uniform velocity perpendicular to one of its sides. The uniform constant magnetic field exists. Mehek will answer. Okay, Mehek, very good question it is shown in the figure. The current induced in the loop is how much? Whenever I told you something, then something. Remember last time only I told you.
It's going out of the plane, so
It is not going out. It is in the magnetic field only.
okay.
It is not coming out, neither it is entering. It is inside only. And it is passing inside only. If you read, यहाँ पर देखो, ये word use किया है यहाँ पर.
So it will be 0.
Why?
Because
ना तो
the
फ्लक्स बढ़ रहा है
magnetic
ना तो
field is constant.
कांस्टेंट है. देखो ये रॉड अगर काटेगा, ये रॉड दिख रहा है आपको, तो इसके अक्रॉस बैटरी ऐसे बनेगा. हमने बनाया था वो रूल है ऐसे.
Yes, sir.
अच्छा, ये भी काट रहा है तो इसके अक्रॉस भी ऐसे बन रहा है. इसका ईएमएफ भी कितना आएगा?
BLV.
इसका भी ईएमएफ कितना आएगा बेटा? BLV. Now apply Kirchhoff's law. Can I say this is E and this is, if you apply this, it will become plus E minus E. नेट
Yes.
जीरो बन गया,
Yes.
समझा क्या?
Yes, sir. Got it.
This was asked again in the NEET exam, and as I told you last time only, I told you कि जीरो आएगा तो जीरो पे सोचो, maximum times answer is zero. Okay. Because the word used over here is constant magnetic field exists along the perpendicular to the plane. मतलब ना तो field बढ़ रहा है ना तो कम हो रहा है, field is constant throughout. So neither the flux is increasing nor decreasing, and परिवर्तन नहीं होगा तो start the story will not start only. Na? That's fine. I hope you all are getting it. Second last lecture is there, so I hope you all are understanding everything. We are coming to question number 69. Okay, listen to me. A loop is made up of straight edges, have 6 corners. Okay, listen to me. 6 corners are there. 0, 0, 0, L, 0, 0. यहाँ पर if I make it this way, can I consider this x-axis, y-axis, and beta this is z-axis? 0, 0, 0 will come here, 1 point. L, 0, 0 will come here. L, 0 will come here. 0, L, 0. So this is one plane which is existing. This is one loop. बराबर क्या? And this is what? What is the length? L. What is this length also? L. You know the coordinates, right? अच्छा आगे क्या बोल रहा है? This is A, B, C, D. Okay, A, B, C, D. Fine. And फिर आगे क्या कह रहा है? E कहाँ पर है? 0, L, L. 0, L, L यहाँ पर आएगा. This point. This is E. And last point F is here. Can I say this is also the loop? Are you getting my point? This is the kind of loop which we want. So there is one loop this way. मतलब ऐसे है ना? Hey man, how will I show it to you? This way. One and like this. Got it? If I, this is a table. If you see the table, so one loop is kept here and other loop is kept here. Are you there with me? This is one loop.
Yes, sir.
And this is another loop. And this is the table. Okay. And the magnetic field which is existing is B naught I cap. B naught I cap मतलब कैसे? Which direction?
X.
X.
X. So can I say there is another B naught I cap? ये B naught I cap है क्या? ऐसे. And there is another B naught K cap. B naught K cap मतलब क्या?
Z.
Z direction. Do you agree with me? Hello. Is this
Yes.
correct or not? एक है I, दूसरा है K. The flux passing through the whole loop. अच्छा कोई बता सकता है? What is general formula for flux passing? अगर ये एक एरिया है, एरिया वेक्टर इधर रहेगा, मैग्नेटिक फील्ड इधर रहेगा, सो फ्लक्स कितना हो जाएगा इस हिस्से से NAB, बट इट इज cos थीटा, बट थीटा जीरो ना बेटा. हेलो हेलो. So can you
Yes.
tell me what is the flux passing through this area? Where is the area vector? Can I see area vector इधर ही है? The flux passing through this area will become N तो नहीं है, एरिया कितना रहेगा इसका L square and B is B naught. बराबर क्या? Can you tell me what is the flux passing through this area? Area vector भी इधर है. How much will be there? L square B naught. So net flux कितना हो जाएगा? 2L square B naught. Hello. And flux is a scalar quantity, no? So we can add them na, directly. So clear है?
Yes.
Simple है. It was two loops which were divided. Okay. So through this area, this was B naught and this was area vector. So flux was NAB. यहाँ पर also it is B naught and area vector are at the same plane. Okay. So that will be the whole case. Fine. once you keep on practicing, कोई दिक्कत आने वाला नहीं है. It is very simple question. 71. It's going very smoothly if you see. Achha, that's very good question. Very good question. Remember in the synopsis, I had told you one thing, that if there is a magnetic field, the whole thing is based on synopsis. And if there is a half loop passing over here like this, and what did I tell you? What do you need to consider? If I want EMF across AB, what do you need to do? Arpita, do you remember what I had told you in the synopsis? What do you need to do? You need to consider the length of the rod as the displacement. Don't consider this a semicircle rod. You have to consider the rod this way. You have to consider the displacement. Can you tell me how much is the length? 2r. And can I say this is going with the velocity v? So EMF induced across this rod will be BLV. That is BL. L is what? 2r beta into v. Hello, bolo. And remember, I tell you which end will be positive and negative. I had told you to use this rule, the Handwaller rule. So where is the magnetic field inside? Where is the velocity down? So can I say this is my palm going this way? So this end will be plus and this end will be minus. Mean this will be represented like a fictitious battery. Whose EMF is going to become B2RV. Do you know this thing? Do you know this thing?
Yes.
Yes, sir. Very good, sir. It is. Okay. We know it. It is there in the synopsis, Baba. I have done this. I am revising it. Now look at this. Two U-shaped loops are there. They are relatively moving to each other. बराबर क्या? Hello.
Yes, sir.
They are relatively moving to each other. Can you tell me both are moving in the same speed? So महक अगर एक को I stop and give the velocity to the other, so how much will be his speed then?
Twice. 2v.
2v. सबको पता है, opposite direction में add करते हैं. तो हम लोग क्या बोल सकते हो कि आप लोग बता सकते हो one of the conducting U tubes can slide in one another, maintaining electrical contact between the tubes. The magnetic field is perpendicular. If each tube moves towards each other with a constant speed v, that the EMF induced on the circuit where in terms of I and V, where L is the width of each tube. Okay, so this part is going the width of each tube. But both are approximately same, they are fitting into one another. They are fitting into one another. Can you tell me what will be the answer? इधर देखो, इसका speed generally if I stop him, देखो ये हो जाएगा, ये L है. इसका speed कितना पकड़ेगी? एक को रोक लेंगे तो 2v. 2v. What will be the EMF induced? B.
Yeah.
Okay. So fine, that is all okay. So this is correct. Now we go to next question. Listen over here. In a closed, so which graph, what versus what graph it is? What versus what graph it is? B by T. D by T. So slope will become dB by dt. Slope will be, Baba, how much is the slope? dB by dt, right? Can I say over here slope is positive and over here slope is negative? And can I say over here how much is the slope at this point?
0.
0. बराबर है. So where dB by dt is 0? At how many seconds?
2.
बराबर क्या? So can I say dB by dt is 0 at t is equal to 2 seconds? dB by dt is 0. And there is no change in magnetic field. So change in flux will also be 0. So how much will be the EMF induced?
0.
This is correct. मिल गया ना आंसर? करेक्ट है क्या? ओके. और एक चीज, ये एक्चुअली मल्टीपल चॉइस में चला जाएगा. कैन आई से यहां पर dB by dt was positive. So EMF was NA dB by dt ना बेटा. If you consider minus sign, whatever. बराबर क्या? तो can I say EMF over here is positive because dB by dt is positive. Over here, what can you say about EMF? It will become negative, na? Hello, yes or no?
Yes.
Where is the direction of the EMF changing and how much time? At how much time this change is happening?
2 seconds.
So can I say direction of the EMF is reduced, will change in t is equal to 2 seconds? This is also correct. Baba sahi hai na? This is also correct. So direction of the induced EMF will change in t is equal to 2 seconds. Power dissipation in 3 seconds. Okay. E का formula हमको पता है. It is NA dB by dt. We have done it. NA dB by dt. Listen to me. What is N given in the question? If you see, 25 is given. Area is given as, radius is given. So it is a square loop. Square नहीं है, circular. तो pi r square हो जाएगा. R is given as 1.8 centimeters minus 2. dB by dt कितना है? इसका डेरिवेटिव ले लो. Take derivative. फटाफट. Come on. What will become? 0.2 minus कितना हो जाएगा? 0.1 t. Are you there with me?
Yes, sir.
And they want at t is equal to how many seconds? 3 seconds. सही है क्या? अच्छा, actual formula is E is minus NA dB by dt. So I'll put minus sign because यहाँ पर when I put 3, this number will go in minus. देखो, minus का बाहर minus will become plus. So EMF का value आपको कुछ आएगा, that will be good. बराबर है? Tell me fast, man. Okay, what are they asking you? Power. Power के 3 formulas है. What are the formulas? Power का एक formula क्या है? EI. I को लिख सकता हूँ E by R. So can I write this as E square by R also? Baba, correct or not?
Yes.
So power is E square by R. You know E square from here. Get R, you get the answer. So this all is manageable for me. Okay, 75. You know this one. Okay. We have done this. Okay, this is a good question. We'll do this also. 74. A rectangular loop with sliding connector of length this much. So this is a connector of length. This length is given. Magnetic field perpendicular. So magnetic field is this way. Can I say is this rod बीच में वाला जो rod है that is cutting the line? This rod is cutting the lines. Yes, sir. It is cutting the lines. It is moving at the velocity v. So this rod is cutting the lines, and okay, since it is cutting the lines, the resistance is 2 ohms and 3 ohms. Okay, let's pay attention to it. Find the current in the conductor. Current. So can you tell me this will act like a fictitious battery? How much will be the value of the fictitious battery? Come on, man, fast. BLV. Acha, what about this 2 and 3 ohms? They are in series or parallel, beta? They are in parallel, right? Are 2 common points are there na battery ka? Yes or no? Hello. This is 2 into 3 upon 2 plus 3. Are you understanding my point? What is current ka formula? P by R. That will be BLV by R 6 by 5. You can do this, okay? I hope you are understanding. Huh? Simple hai? Okay. Achha, one more thing is there. Can I say ये connector का भी resistance 1 ohm है. इसके पास भी resistance 1 ohm है. तो भी थोड़ा बदल जाएगा. What will be R net equal to now? R net will be 6 by 5 plus 1 ना बेटा. हेलो. तो ये हो जाएगा 11 by 5. That is okay. So this will be 11 by 5. Answer. Correct. This is R net. These were all done initially also. Okay, sir. Very good, sir. Very good. Look carefully here. We are doing the 75th question. Good question. Listen. So when current in proportion, the portion of the circuit shown is 2 ampere and is increasing at the rate of, so can I say current over here is 2 ampere and increasing at the rate of the di by dt is given as 1 ampere per second. Potential difference across AB is given as 8 volt. And second case mein when the current is 2 ampere and decreasing at the rate of, the minus di by dt is given is 1 ampere per second. The potential difference across AB is 4 volt. The value of R and L. Now look carefully. I will apply Kirchhoff's law by taking my finger in this direction. बराबर क्या? So can I say VA minus IR minus L di by dt, if you remember, is equal to VB. So VA minus VB is equal to plus IR plus L di by dt. There will be two equations made. VA minus VB in the initial case is given as 8 volt. I is given as 2 R. I don't know L kitna hai. L bhi pata nahi hai. Di by dt in the first case is given as 1. So 8 is equal to 2R plus L. This is equation 1. Second equation, if I apply this again, this equation again, if I apply, it will become 4 volt is equal to IR. I is 2R plus L. But di by dt in the second case is negative, so it will become minus 1. So second case में ये हो जाएगा 4 is equal to 2R minus L. Can I add both of them? So it will become 8 or 12 and 4R. ये तो cancel हो जाएगा. तो R will become equal to 3 ohms. And once R is 3 ohms, put it here. So A2 will become 2 3s are 6 plus L. So L will become 2 Henry. Bolo. The very favorite question. Okay. And this is typically neat type question. Average level. Okay. You just need to apply Kirchhoff's law from A to B. And once you apply, you get the result. Always remember, whenever they tell you decreasing at the rate of, ये minus sign लेने का. If they tell you it is decreasing at the rate of, obviously it has to take, you have to take minus and it will become 3 and 2. 3 and 2. This is the answer. Okay. Question number 76 is a nice question again. Look carefully. Two different coils of self-inductance L1 and L2 is 2 Henry. Listen to me. Now, this is good question. The current in one coil is increasing at a constant rate. The current in the second coil is also increasing at the same rate. And the what is constant? Di by dt in both the loops is what, sir? Constant. Remember this thing. Huh? At a certain instant of time, the power given to the coils is also the same. So power is also the same. At that time, the current, the induced voltage and the energy stored in the first coil is I1, V1, W1. Corresponding values in the second coil is I2, V2, W2. Then choose the wrong options. Listen to me, now. There are coils. Can I say EMF induced across the coil, that is inductor, is L di by dt? But I know that di by dt is constant, beta. The EMF induced in loop 1 to EMF induced in L2 will be proportional to L1 is to L2. What is L1 given? 8 by 2. It will become 4 is to 1. This is first answer. So E1 by E2 has to be 4 is to 1. E1 by E2 is, so V2 by V1 is 1 is to 4. This is the correct option, but I need the wrong option. Hello, I need the wrong option. So ये correct है. ये पहला मिल गया, ठीक है? Now second part, what are they telling you? Current चाहिए. अच्छा, power, you know, power is EI, but power is constant. If you know that power is constant, that means E1 I1 will become equal to E2 I2 because power is constant. Hello. So can I say I1 upon I2 will become E2 by E1, and E2 by E1 आप यहाँ से ले सकते हो, will become 1 is to 4. So what is I1 by I2? 1 is to 4. I1 by I2 is 1 is to 4. This is wrong statement. Na? So actually this is my correct statement. Arey bhai bolo, yes or no? We have asked you the wrong statement. So if you see, this is wrong statement, na beta. Hello.
Yes.
And if they ask you about power, they ask you about energy. Energy का formula क्या? Half Li square. So energy 1 upon energy 2 will become L1 upon L2 into I1 upon I2 the whole square. So L1 upon L2, if you see that it is 8 is to 2. And I1 upon I2 is 1 is to 4 का square will become 1 is to 16. ये हो जाएगा 1 is to 4. That is also correct है. देखो ये भी correct है. तो मतलब सब कुछ correct है सिवाय इस आंसर के. इससे क्या होगा? आपके formulas revise हो जाएंगे. So in case of an inductor, whenever they tell you it is an inductor, the EMF induced across the inductor is L di by dt. The power induced is EI, and the energy is half Li square. If you remember this, you know the sum. If you don't know, you can't do the sum. And they have asked you the wrong statement, huh? That you need to remember. Fine. Done. Question number 78. Since we have done it before also. Mehak, your question again. We have done it before, huh? Where the slope is 0 in the, this is the main graph. This is the question wala graph. Can I say here di by dt is how much? 0.
0.
Here di by dt is what? Negative. Here di by dt is what, beta?
Positive.
Can I say where here EMF induced will be? In this region, how much will be the EMF induced? 0.
0.
Because E का formula याद है ना, is L di by dt. Or you can take minus L di by dt. सही है क्या?
Yes.
यहाँ तक तो 0 है. फिर यहाँ पे di by dt is negative. So can I say EMF induced will be positive?
Yes.
और यहाँ पे di by dt is positive. So can I say EMF induced will be
Negative.
yes. ठीक है. This was done before also. Same repetition is happening again and again. 2-3 lectures to only we do revision only. Same thing. $79. Listen to me. This is thoda hatke question. Okay, we know the stuff. Hey, who's this? Where is everyone gone? Hi. When I tell something, everyone will switch on the video. Huh? Asmi, where are you? Kartiki. Okay, in a circuit shown, the coil has inductance and resistance. Acha, Balse, what is the formula for tau in case of inductor? Tau is
L by R.
perfect. ये formula सबको आता है, ठीक है? Because they have used L by R over here, so we know tau how use it. When X is joined to Y, मतलब इसको ऐसे join करो. तो can I say ये सर्किट ऐसे बन जाएगा, ये बैटरी EMF है, इसको ज्वाइन कर दिया मैंने, ये इंडक्टर है. कैन आई से इधर करंट जाएगा, करंट इधर मैग्नेटिक फील्ड बनाएगा, एंड व्हाट विल बी द मैग्नेटिक फील्ड? हाफ एल आई स्क्वायर. इतना मानते हो स्टार्ट में? निष्का, at time 0 it will act as inductor, at time 0 acts as short circuit, at time infinity acts as
Open circuit.
ऐसे होता है कि कैपेसिटर में ऐसे होता है.
Sorry, sir.
नहीं, आई एम आस्किंग यू, सॉरी हो रही नहीं है, टेल मी करेक्ट है कि रॉन्ग है? who behaves like open, who behaves like short initially? What can you say? हाँ सही है, तो मिस्टेक नहीं करना, अगर रॉन्ग हो जाएगा सर. तो कैन आई से दिस इज एट टाइम इंफिनिटी, बराबर क्या? इट विल एक्ट एज व्हिच सर्किट?
Short circuit.
शॉर्ट सर्किट. स्टार्टिंग में तो ही इज अपोजिंग ना यार, ही इज आवर अमिताभ बच्चन, राइट? परिवर्तन he doesn't like in the start, right? But gradually what will happen? He will adjust, हाँ? बराबर है क्या? The time constant tau during the growth of current. So tau, as Balse had told me, tau is equal to L by R. When a steady current is reached, the heat produced in the coil is P. And the heat produced is this only. Energy is heat produced is P, given half L I square. Getting it? Heat produced in the heat produced in the coil. Heat produced is not this. This is the energy stored. Heat produced का formula अगर आपको याद है, is I square R. Joules heating, na? Hello, it is actually I square R T, but you are taking per second. Hello, मालूम है ना? Per second. If now it is joined to Z, देखो एक्चुअली क्या हुआ, पहले एनर्जी इसमें भर दिया हम लोगों ने हाफ एल आई स्क्वायर. फिर क्या हुआ? फिर हमने ये इंडक्टर को जिसमें एनर्जी भरी हुई थी, इसको हमने बैटरी से निकालकर इधर एक शॉर्ट वायर के यहाँ पर कनेक्ट कर दिया. तो कैन आई से ये जो हाफ एल आई स्क्वायर है, कैन आई से दिस विल पास करंट एंड दिस विल डिस्चार्ज द करंट, एंड सपोज यहाँ पर एक रेजिस्टर है, इट विल डेसिपेट द हीट फ्रॉम द वायर. करेक्ट है? समझ में आ रहा है क्या? इनिशियली यू आर Initially, what are you doing? You are filling up the inductor with energy. And how much is the energy stored in the inductor at time infinity? Half Li square. Then you remove the battery and you are making the connection this way. So can I say whatever energy has been stored in the inductor will release it through the wire? Are you there? Did you understand what am I trying to tell you? Simple, eh? Okay. How to? Can you tell me? Which energy is converted to which energy? Mehak, initially which energy is there?
Potential.
Half Li square.
Half Li square.
And which energy it wants to dissipate in?
Heat.
Heat. So can I say half Li square is dissipating as I square R? बोलो ये करेक्ट है क्या? हेलो, ये चीज सही है? ये होने वाला है, ठीक है, but they are not asking you this thing. They are asking you the total heat produced in the total heat produced. So total heat produced in terms of total heat is half Li square only. We can write this. Can I say the heat produced is half Li square, which is I square R also. Okay. Which is I square R also. So this is also I square R. So can you tell me if I need the answer in terms of P? In the answer, I have to retain P and remove this Li square. सही है क्या? अरे भाई, whole answer should be expressed in terms of P. You can see the answer is in terms of P. So if I know that power is I square R, can you tell me what is I square equal to? P by R. Can I say half L P by R? ये सही है क्या? Hello, 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 hello. And what is tau is L by R? So what is L equal to? What is L equal to? Tau R. Can I say L will become equal to tau into R? P by R cancel. Half P tau is the heat produced. Half P tau. It should be half P tau. Okay. Half P tau होना चाहिए. P tau missing है क्या? tau होना चाहिए. Answer is B. Half P into tau. $81. Okay, listen to this question. It's an important question. Pay attention to me, everyone. Two coils A and B as shown in the figure. Current starts flowing in B as shown in the figure. They have not shown. Just check the question. Current is shown in this way. Is this current clock or anti-clock?
Anti-clock.
This is behaving like which pole?
Not.
No. They have given you in the question. They have given you in the question. That means which face of the coil is approaching him? A वाला. अगर ये खुद north बन रहा है, मतलब आने वाला कौन है?
South.
No यार, how will it oppose the cause? ना?
Yes, sir. North.
तो ये जो coil है, अगर ये ऐसे आ रहा है, तो ये north है ना बेटा? तो ये north बनेगा. Hello, are you understanding? I'll represent this like this, na beta. This is north and this is south. Are you getting my point? North is coming near, na? Therefore it will produce north. ये तो सही है. When A is moved towards B and stops, okay, when A stops moving, the current A is counterclockwise. B is kept stationary when A moves. We can infer that. Balse, what can you infer? A में कौन सा डायरेक्शन ऑफ करंट फ्लो हो रहा है?
एंटी क्लॉकवाइज.
हाँ. एंड इज द करंट कांस्टेंट और वेरिएबल? ये बहुत इंपॉर्टेंट पॉइंट है. अभी ये बालसे ने तो ये बोल दिया कि देयर इज अ काउंटर क्लॉकवाइज करंट. बराबर, इतना सब लोग मानते हो? अरे देखो ना यार, ये काउंटर क्लॉकवाइज ही तो है. यस और नो? हेलो, सब लोग ये मानते हो? अर्पिता, डू यू अग्री? ये सब लोग मानते हो. सिद्धि, डू यू अग्री? ये ठीक है, ये सब लोग मानते हैं यार, ये तो हम लोग कर चुके हैं. Now can you tell me, is this current a constant current or a variable current? This is a very beautiful question. दो पार्ट है ना इसमें. ये तो सही है, दूसरा वाला सही है कि गलत है? देखो, अगर ये वेरिएबल होता, सुनो हाँ मेरी बात, सुनो सुनो, लुक ओवर हियर. अगर ये वेरिएबल होता तो ये रुका हुआ भी रहता तो इधर इंड्यूस होता करंट. बिकॉज करंट चेंज होगा तो फील्ड चेंज होगा, फील्ड चेंज होगा तो ईएमएफ आएगा, ईएमएफ आएगा तो यहाँ पे प्रोड्यूस करेगा. बराबर है क्या? हेलो, व्हाट इज ही टेलिंग यू? व्हेन ए स्टॉप्स, व्हेन ए स्टॉप्स, करंट बिकम जीरो. ए भाई, अंडरस्टैंड और नॉट? तो मतलब जब तक ये चल रहा है तब तक यहाँ पे करंट आ रहा है. ये रुक जा रहा है तो कुछ नहीं हो रहा है. ये रुक जा रहा है, इसमें कौन सा? दैट मींस नॉर्थ पोल ओवर हियर द फ्लक्स हैज बिकम व्हाट? कांस्टेंट. ना, देयर इज नो वेरिएबल मैग्नेटिक फील्ड. सो दैट मींस दिस करंट ओवर हियर इज व्हिच करंट?
Constant.
Constant current. If this would be a variable current, then if he would stand also over here, no, then he would produce EMF over here. Meg, did you get?
Yes, sir.
परिवर्तन होना चाहिए ना. So if he is standing and doing परिवर्तन, then also EMF will be induced. But ये क्या बोल रहा है क्वेश्चन में कि ये जब रुक गया तो करंट भी रुक गया. तो ये जब रुका करंट भी रुक गया, दैट मींस उसमें कांस्टेंट करंट फ्लो हो रहा है. इंपॉर्टेंट है. हाँ, ना प्रॉब्लम हो जाएगा. Balse, you have some doubt? No, no doubt. Okay, no doubt. Fine. Eighty-fourth question. 82nd is the same type only. It is all, these are all questions taken from NCRT. This is an NCRT question. 82nd is also NCRT. Try करना करता है. I'm going to 84. Now this loop is not this way. It is this way actually. थोड़ा diagram wrong है. Okay, this is there. ऐसे कुछ है, ठीक है. ये wrong है, ऊपर वाला आएगा. Okay. Figure shows a certain wire segment joined together to form a coupling or loop. ये दिख रहा है coupling. The loop is placed on a magnetic field going into the plane. You can see the magnitude of the field is increasing. This dot is increasing. Okay, beautiful. Huh? Now listen to me. What is going to happen? Okay, so they are telling you this is A, B, and ये बाहर वाला है C, D. अर्पिता,
Yes.
क्रॉस बढ़ेगा फील्ड. So he will produce which field inside him? Dot. So he needs to induce dot field. For dot field to be induced, dot मतलब बाहर ना, the direction of the current will be Anti.
Anti-clockwise.
Sir, now this is the problem. Huh? Listen to me now. You know anti-clockwise. Okay, everyone will tell me anti-clockwise. ये तो पूरा नहीं 2 हफ्ते तक 3 हफ्ते तक हम लोग वही कर रहे हैं anti-clockwise. Yes or no?
Yes.
Now always remember that thing. Always remember one thing, that the current in the outer loop will be anti-clockwise because that is the dominant loop, ना? अरे यहाँ पे 2 लूप है भाई, दो देखो ना, एक छोटा वाला लूप है, दिख रहा है ये, और एक बड़ा वाला लूप है, दिख रहा है?
Yes, sir.
Always remember ये चीज कि current in the outer loop will be the main current which we want. Okay, so if we want anti-clockwise current, can I say current in the outer loop is going to become ऐसे, फिर ऐसे जाएगा, फिर ऐसे जाएगा, फिर ये ऐसे टर्न करेगा, ऐसे जाएगा, ऐसे जाएगा, और फिर ऐसे जाएगा. बोलो सही है क्या? हेलो.
Yes, sir.
हाँ, so current is flowing from, in the outer loop is flowing from D to C. D to C. Hello.
Yes.
And current in the inner loop is flowing from A to B. अरे देखो ना यार, ये D to C and A to B. So D to C and A to B in the inner loop. And current is same, हाँ, ऐसे नहीं है कि ये current अलग है और ये current अलग है, एक ही loop है, एक ही current है, पूरा एक ही जा रहा है ना, एक ही series में है ना सब. So I1 is in the direction of DC. नहीं, I1 अंदर वाला है क्या? Oh sorry, this is I2. This is I2 and this is I1. So I1 is going from
A to B.
AB and I2 is going D to C. ये important है, हाँ, important है. What is the rule? The outer loop should dominate. The outer loop should dominate. The outer loop should dominate. Okay, sir. Very easy, sir. Very easy. अरे भाई क्या है भाई, इतना सिंपल. Friday भी again we are doing, तो अभी और practice है. Then practice lecture will also come. भाई उससे ज्यादा क्या करेंगे, right? Okay. '85th. See now, listen to me here. A uniform magnetic field exists in a cylindrical region. You can see this is the cylindrical region. Correct? Very good, very good. Of radius 10 centimeters. So radius is 10 centimeters. So this will become 20 centimeters diameter. A uniform wire of length 80 centimeters and resistance this much is bent in the form of square frame. So 80 centimeter का वायर है, उसको स्क्वायर बनाएंगे तो महक एक साइड कितना हो जाएगा? Hey man, come on. 80 सेंटीमीटर का पूरा वायर है, उसको स्क्वायर बनाएंगे तो एक लेंथ कितना हो जाएगा? 20 only man, 20 only. And it is kept in this manner. It is kept in this manner. How, which manner it is kept? It is kept like this. Can I say it is fitting along the diameter? Hello, hello, hello. It is fitting along the diameter. बराबर है. And resistance कितना इसका 4 ohms है. Placed with one side of the diameter along the cylindrical region. The magnetic field increases at the rate of, so can I say dB by dt is given as 0.010 Tesla per second. The current induced in the frame, I चाहिए, I का फॉर्मूला है E by R. बेटा E को लिख सकते हैं NA dB by dt. Do you agree with me now? Hello? अरे हाँ ना बोलो man.
Yes, sir.
Number of turns कितना है? 1 है, 1. अरे इसका number of turns 1 ही है ना. ये जो loop है, ये जो loop है ना, white color का जो loop है, ये square frame जो है, इसका number of turns. Can you tell me? Okay. ये यहाँ पर ध्यान से, हाँ सब पे अटेंशन टू इट. हाँ, एरिया कितना है? एरिया ऑफ द लूप नहीं है, दिस इज द एरिया ऑफ द मैग्नेटिक फील्ड। या तो हम लोग एक काम करते हैं दूसरे, ये डायरेक्ट फॉर्मूला अप्लाई नहीं करता, मैं तोड़ तोड़ के आपको बताता हूँ ताकि आपको समझ में आएगा। Can you tell me what is the flux linked with the coil? Flux linked with the coil will become NAB. This is better. What is flux? N is given as 1. Area is what? Area of the loop placed in the magnetic field. How much is that? Area of the loop placed in the magnetic field.
Pi r square by 2.
Area of loop placed in magnetic field. This is important. नॉर्मली पीछे के सम्स में क्या होता था, पूरा एरिया वाज प्लेस तो पूरा एरिया लेता था, तो यहाँ पर ऐसा नहीं है, इट वाज पाई r square by 2 into b. So pi r is given as what? R is 10 centimeter, 0.1 0.01 हो जाएगा by 2 and b. So can I say d phi by dt, ये बन जाएगा, इसका डेरिवेटिव निकालो तो बन जाएगा e which is d phi by dt will become pi into 0.01 divided by 2 into dB by dt. And dB by dt कितना दिया हुआ है, ये दिया हुआ है, into 0.010. This was EMF. And then we need current. Current will become E by R. Same thing. So the only catch over here, we knew all these things. Only the catch was A. ये का ध्यान रखना है. Normally सब लोग एरिया कितना लेंगे, L square लेंगे. People will take area as L square. That A is not that area of the magnetic field which is placed inside the loop. बाकी सब आपको आता है. So this much is the area which we consider. So the area. Okay. Now, series of 3 questions I'm doing. 3 questions are important. Pay attention. 87, 88. 89 is simple only. So 87 and 88. You all be there with me here. A wire of length 10 centimeter translates in the direction 60 degree with its length. 60 degree with the length. बराबर क्या? 60 degree with its, what's the length? No? Is the length vector. No? The plane of the motion is perpendicular to the uniform magnetic field that exists in the space. Yeah. Now look carefully. What is the trick? I told you. See, if there is a magnetic field, I have told you that if there is a rod and the velocity is perpendicular to the length, then the EMF induced over here is BLV. This is V perpendicular actually. बराबर क्या? Because that much part is cutting the lines, ना? अच्छा, what will be V perpendicular in my diagram now? We need this. And this is also V cos theta, but V cos theta component is not doing anything. Remember, it has to cut lines. So V cos theta is not doing anything. V sin theta is cutting the line. Na? So what will be the EMF induced? BL V sin theta. B कितना है ये कैलकुलेट कर सकते हैं आपको, ठीक है ना? हेलो. BLV sin theta. BLV sin theta. Remember, it has to be perpendicular velocity to the length. This velocity is important. It should be V perpendicular. Actual formula is BLV perpendicular. Because it has to cut the lines, and for cutting the lines, it should be perpendicular to the magnetic field. Okay. Okay, listen to me. A loop moves with the velocity v. So there's a loop, but this is open circuit loop, and this length is given as L by 2. Okay, and the B is directed this way. Look over here. Can I say this is like this, which I had explained it right now? What has to be done? What should I do? Arey bhai, what should I do?
Take the
You
displacement.
can take the displacement, make it a rod, imaginary rod. What will be the EMF induced? BL, but L is 2R into V. Do you agree with me? अच्छा, यहाँ पर what will I do? यहाँ पर what will I do? ये P और Q है. What will I do? What is the displacement,
Take L
beta?
by 2 as the
Very good, very good. Done, done. So I'll take this and I'll move this. What will be the EMF induced?
ELV by
BL by 2 into V, na? That is BLV by 2. Correct है क्या? And can you tell me which terminal will be plus and minus? We know this is acting like a fictitious battery this way, na? I really remember now. Hello, this one. So this will be upper end will be plus and lower end will be minus. So P is positive with respect to Q. So answer is 1 and 3. 1 and 3. Where is 1 and 3, sir? 1 and 3. Upper end will be positive because fictitious battery is this way. What rule? So many fingers. Okay, no problem. Right? Okay. B. V. Positive terminal. Getting it? Yes. Chalo. Aage. Very smoothly it happened. Not? No problem. Okay. Last question. Okay. And 89. Totally down. A conducting loop is being pulled out of the magnetic field. Which of the plots is power delivered by pulling agent? If you remember, Nishka, last question to you.
Yes.
Power delivered का formula क्या है? If you remember, I had given you in the synopsis. B square L square V square by R. If you remember. Yes sir खाली बोल दो. Yes sir तो बोल देगे तो yes sir हो जाएगा. ठीक है? You know this formula. How did it come?
That I don't remember.
That you don't remember. That तो नहीं है. तो देखो एक्चुअल फॉर्मूला क्या था? एक जब ऐसे लाइंस को कट करता है तो हमको मालूम है कि ये कट करेगा तो ईएमएफ कितना आएगा? BLV. करंट कितना आएगा बेटा? E by R. इसके ऊपर याद है एक पीछे फोर्स लगेगा, मैग्नेटिक फोर्स. लेंज लॉ के मुताबिक इट विल बिकम बिल which will become B square L square V by R, and the power which need to be supplied by the external agent will become equal to FV. याद आ रहा है कुछ?
Yes.
B square L square V square by R. And can you tell me this power which I am applying instantaneously is power delivered across the resistor also? B square L square V square by R. Do you remember the story now?
Yes, sir.
तो ये वही फॉर्मूला है जो हम बात कर रहे हैं. करेक्ट. अच्छा, कौन सा ग्राफ इज प्लॉटेड विद व्हाट वर्सेस व्हाट? यहां पर बराबर नहीं है. व्हाट वर्सेस व्हाट? कैन आई से पावर वर्सेस बी? पी और वी का रिलेशन क्या है इसमें? पी और वी का रिलेशन क्या है? पावर इज प्रोपोर्शनल टू
Square.
तो क्या कैसा ग्राफ आएगा? पैराबोला, स्ट्रेट लाइन, सर्कल?
Para.
पैराबोला. दिस इज देयर, सो दिस विल बी द आंसर. हेलो बोलो, यस और नो?
Yes.
डन. सो व्हाट इज द आंसर ओवर हियर? दिस विल बी द आंसर. ये जो भी है देख लेना. Out of all the graphs, this graph is there. So answer is, I think this is B.
Yes. B.
ठीक है? Yes, sir. Yes, sir. Correct है?
Yes.
So we'll start from 90 and फिर 10 10, 12 sums are left that we finish it off. आखिर के I think आखिर के तो 10 question है ही नहीं क्वेश्चन में. So that will be done accordingly. चलो, thank you, take care, bye.
Thank you, sir.
Thank you, sir.
Thank you.